close your eyes for a moment, or let them rest gently on the screen, and imagine this with me. You step outside just before dawn. The air is cool and still. You look up, and stretching across the entire sky, from one horizon to the other, is a luminous arc of light. Delicate, shimmering, silent. Earth has rings. Not the rings of imagination or fantasy, but real ones. Bands of ice and rock orbiting our planet, catching the first light of the sun before it even touches the ground. They glow softly in shades of silver and pale gold, casting shadows across continents, visible from every point on Earth where the geometry allows. It would be one of the most beautiful sights in nature, and it would change everything. Tonight, we're going to explore what would happen if Earth had rings like Saturn, not in quick facts or rapid summaries, but slowly, carefully, the way the universe itself unfolds. We'll walk through 5 stages together, 5 transformations that would ripple through our world, our sky, our lives. Some of them are wondrous, some of them are dangerous, all of them are worth understanding. Before we dive in, if you enjoy these explorations of space and our cosmic perspective, a quick like or subscribe would really help this channel grow. It's a small gesture, but it allows us to keep creating these calm journeys through the universe together. Now, settle in. There's no rush here. You can stay as long as you'd like. We'll move slowly through this together, and if you drift off along the way, that's perfectly fine. The universe will still be here when you return. Let's begin with a simple question. What would it actually take for Earth to have rings? Not magic, not sudden cosmic theatre, but the slow, patient mechanics of gravity, collision and time. Rings don't appear, they form. They're built from debris, shattered moons, captured asteroids, the remnants of something that came too close and broke apart under the pull of our planet. Saturn's rings are made of billions of fragments, some as small as grains of sand, others as large as mountains, all orbiting in a flat disk around the planet's equator. If Earth had the same, we'd inherit that same structure. A glowing band, aligned with our equator, visible to half the world every night. It sounds peaceful. And in some ways, it would be. But rings are not just beautiful. They're active. They fall. They block light. They interfere with orbits and alter climates, and make the sky both more wondrous and more complex than we've ever known. Over the next hour or two, we'll explore what that means. We'll walk through the 5 stages, the formation, the shadows, the navigation, the debris, and the long, slow transformation of life on a ringed Earth. We'll move gently, we'll take our time, because the universe has been here for billions of years, and we have all night. So here we are, standing under a sky that humanity has never actually seen, a sky decorated with rings. Before we step into the details, let's take a moment to understand what we're really exploring together. This isn't a story about catastrophe. It's not about the end of the world or some sudden disaster that wipes everything away. It's about transformation. It's about how one cosmic change, one beautiful, dangerous addition to our sky, would ripple through everything, through weather patterns and navigation systems, through the way birds migrate and the way ancient civilizations would have told their stories, through technology, ecology, culture, and time itself. We're going to walk through 5 stages, 5 layers of consequence that unfold when you add rings to a planet like ours. Stage 1 is formation, the slow, quiet process of how rings come to be. We'll explore the mechanics of it, the collisions and the gravity, and what you might actually witness if you were alive during those early days when debris first begins to settle into orbit. Stage 2 is light and shadow. This is where things get visually stunning and ecologically complex. Rings don't just sit there glowing, they cast shadows, huge sweeping shadows that move across the planet's surface. Some parts of Earth would live in permanent twilight for portions of the year. We'll explore what that does to temperature, to seasons, to the rhythm of life itself. Stage 3 is about navigation. For thousands of years, humans have looked to the stars to find our way. Sailors used constellations. Travellers used the North Star. But if Earth had rings, they would dominate the sky. They'd obscure stars. They'd become the most prominent feature overhead. How would that change the way civilizations developed? How would we have learned to navigate a world where the sky itself looked so different? Stage 4 gets into the debris problem. Rings aren't static, they're made of particles, and those particles don't stay in orbit forever. Some of them fall, slowly, yes, but constantly. And in the modern age, where we rely on satellites for communication, GPS, weather monitoring and more, a sky full of falling debris becomes a serious issue. We'll talk about what that means for technology, for space exploration, for our ability to function as a connected global society. And Stage 5 is the long view. What happens over centuries and millennia? How does life on Earth adapt to a ring sky? How do ecosystems shift when light patterns change? What becomes normal for species that evolve under these conditions? And what does it mean for us, for human beings, to live generation after generation under a sky that reminds us every single day of our place in the cosmos? These stages aren't disasters. They're not meant to scare you. They're meant to help us understand complexity. The way one change in the universe creates a cascade of other changes, some beautiful, some challenging, all interconnected. We're going to take our time with each one. There's no quiz at the end. No need to memorize anything. Just let the ideas wash over you, the way light from those imaginary rings might wash over the Earth. You're here, I'm here, the universe is patient. Let's continue together. Let's begin at the beginning. How do rings form around a planet? It starts with something coming too close. A moon, perhaps, wandering inward over millions of years, its orbit slowly decaying. Or an asteroid, captured by Earth's gravity, pulled into a path it can't escape. Or even a collision, two objects meeting violently in the space around our planet, shattering into thousands of pieces. Whatever the cause, the principle is the same. Something breaks apart within a specific zone around Earth called the Roche limit. The Roche limit is the distance at which a planet's gravity becomes stronger than the gravity holding a smaller object together. Get too close, and tidal forces simply tear you apart. For Earth, that limit sits roughly 11,000 miles above the surface, closer than our moon, but far enough that most satellites orbit safely beyond it. But imagine a small moon, maybe one we captured long ago, drifting closer over geological time, slowly, imperceptibly, until one day, cosmically speaking, it crosses that threshold. It doesn't explode. That's not how gravity works. It crumbles, it stretches. Pieces drift apart, gently at first, then faster as tidal forces increase. Within hours or days, what was once a solid body becomes a stream of debris, each fragment now orbiting Earth independently. And here's the beautiful part. Those fragments don't scatter randomly. Gravity organizes them. Over weeks and months they settle into a flat disk, aligned with Earth's equator, spreading outward in a shimmering band. The rings have formed. Now, what would we actually see during this process? If you were standing on Earth during the formation, you might not notice anything at first. The moon, or asteroid, breaking apart would be happening in space, too far away for the naked eye to catch the details. But within days, you'd start to see something strange in the sky. A faint line of light, stretching from horizon to horizon. At first, it would look almost like a pale cloud, a thin silvery thread cutting across the darkness. But night by night, it would grow brighter as the debris spread and flattened. Sunlight would catch the particles, especially just after sunset or just before dawn, illuminating them in soft, ethereal colours. Children would point at it, artists would paint it, scientists would scramble to understand it. and within a few months it would become undeniable. Earth had rings. The formation itself would be relatively gentle from our perspective. No fiery meteors raining down. Not yet. No catastrophic impacts. Just the quiet redistribution of mass in orbit, guided by gravity's patient hand. But even in those early days, subtle changes would begin. The rings would reflect sunlight back down to Earth, brightening the night sky in equatorial regions. People living near the equator would notice that nighttime wasn't quite as dark anymore. There'd be a faint glow overhead, a kind of cosmic nightlight that never went away. Astronomers would scramble to calculate the composition of the rings. Are they ice, rock, metal? How wide are they? How thick? Will they last 1,000 years or 1,000,000? And slowly the realization would set in. This isn't temporary. This is the new sky. The rings would continue to evolve, of course. Collisions between particles would grind some fragments into dust. Gravitational resonances, subtle tugs from the moon, would create gaps and waves in the structure, like the divisions we see in Saturn's rings. But the core truth remains. Once formed, rings are stable. They settle. They endure. And now, Earth is no longer just a blue marble. It's a ringed world. From space, astronauts, if we still had the ability to launch them safely, would see our planet transformed. The familiar sphere of blues and greens and whites, now circled by a luminous halo, delicate and vast. It would be breathtaking, and it would be just the beginning of the changes to come, because rings don't just sit there passive and pretty. They interact with light, they cast shadows, they alter the way energy from the sun reaches the surface of our planet, which brings us to the second stage, but we'll get there slowly. There's no rush. Rest if you need to. Let your mind wander. The rings are patient, and so are we. Now the rings are here. They've settled into orbit, glowing softly in the night sky, visible to billions of people across the planet. But rings don't just reflect light. They also block it. And this is where things begin to change in ways that ripple through the entire Earth system. Let's think about shadows for a moment. You're familiar with them. The shadow of a tree, the shadow of a building, the brief darkness that passes over you when a cloud drifts in front of the sun. Shadows are temporary, localized, small scale. But the shadow of a planetary ring system? That's something else entirely. Imagine a band of material thousands of miles wide, orbiting directly above Earth's equator. When the sun shines on those rings, they cast a shadow, a massive, sweeping shadow that moves across the surface of the planet below. This shadow isn't small, it isn't brief. Depending on the season and the density of the rings, it could stretch hundreds or even thousands of miles across, darkening entire regions of the Earth for hours at a time. And here's the key. The shadow doesn't fall randomly. It follows a predictable path, determined by the tilt of the Earth's axis and the position of the sun. During the equinoxes, those 2 times each year when the sun sits directly above the equator, the rings would be edge-on to the sunlight. Their shadow would be a thin line, barely noticeable. But as Earth tilts through its seasonal cycle, the rings would tilt too, and their shadow would sweep north and south across the tropics. If you lived near the equator, you would experience something unprecedented. A daily eclipse. Not a total eclipse, like when the moon blocks the sun. But a partial, persistent dimming. A band of cooler, darker air moving across your region every single day. The sun would still shine, but filtered, softened, reduced in intensity. And that changes everything. Let's start with temperature. Sunlight is energy. It warms the oceans, drives the weather, powers photosynthesis in plants. When you reduce the amount of sunlight reaching a particular region, even by a modest percentage, you cool that region down. Equatorial areas, normally the hottest parts of Earth, would become cooler under the ring shadow. Not freezing, but noticeably different. The tropics might feel more like temperate zones during certain times of year. Rainforests might shift their boundaries. Ocean currents, driven by temperature differences between the equator and the poles, would adjust their flow. Weather patterns would change. Monsoons might weaken or shift. Hurricane formation, which depends on warm ocean water, could become less frequent in shadowed regions. Now, this doesn't mean Earth becomes uninhabitable. Life is resilient. Ecosystems adapt, but the changes would be real, measurable, and long-lasting. Plants, for example, would need to adjust. Species that evolved in bright direct sunlight might struggle in the dimmed conditions under the ring, shadow. Others, shade-tolerant species, might thrive and spread. Over generations, forests would shift their composition. New balances would emerge. Animals would adapt too. Migration patterns might change. Birds that navigate by the sun would need to adjust their internal compasses. Nocturnal creatures might find the ring-lit nights too bright and shift their behaviour. But perhaps the most profound change would be psychological, cultural. Think about what it means to live under a sky where shadows move not just from the sun and moon, but from the rings themselves, where twilight can arrive not because the sun is setting, but because the ring shadow is passing over. Ancient peoples would have noticed this immediately. They would have tracked the shadow's movement, woven it into their calendars, their myths, their understanding of the cosmos. The rings would have been gods, or dragons, or celestial rivers, permanent features of the sky that demanded explanation. In equatorial cultures, the daily passage of the ring shadow might have become a sacred time, a moment of coolness and dimness in the middle of the day, when the world grows quiet and strange. And at night, the rings would glow. Reflecting sunlight even after the sun has set, they'd create a band of soft illumination across the sky. People living beneath them would never experience true darkness. The rings would be a permanent nightlight, a ribbon of silver cutting through the stars. It would be beautiful, eerie, constant, and it would mean that half the world, everyone living more than about 30 degrees north or south of the equator, would never see the rings at all. Because of geometry, because of perspective. If you lived in London, or Toronto, or southern Argentina, the rings would sit forever below your horizon, invisible, known only through stories and photographs from travellers. Two worlds on one planet, those who live under the rings and those who only dream of them. We'll explore what that means next. But for now, rest in this image, a world half-shadowed, half-lit, forever changed by the silent presence of debris in the sky. Let's travel back in time for a moment, not to a ringed Earth, but to our own history. Picture a sailor in the ancient world, standing on the deck of a wooden ship in the middle of an endless ocean. No land in sight, no GPS, no radio, just the sea, the wind, and the sky. How does this sailor know where they are? How do they find their way home? They look up. They find Polaris, the North Star, hanging steady above the northern horizon. They trace the arc of constellations across the night. Orion, Ursa Major, the Southern Cross. They watch the moon wax and wane, marking the passage of time. They note where the sun rises and sets, how high it climbs at midday. The sky is their map. The stars are their compass. For thousands of years, this is how humanity navigated. We read the heavens, we memorized the patterns, we passed down knowledge from generation to generation about which stars meant north, which meant south, which would guide us home. But now imagine that same sailor looking up at a sky dominated by rings. Everything changes. The rings would be the most prominent feature in the night sky, brighter than any constellation, wider than the Milky Way, impossible to ignore. For anyone living within about 30 degrees of the equator, the rings would stretch from horizon to horizon, a glowing arc that never moves, never sets, always there. And they would obscure the stars. Not completely. The rings aren't solid, they're made of particles with gaps between them. Starlight would still shine through, but the brightness of the rings, especially when catching sunlight just after dusk or before dawn, would wash out fainter stars. Constellations would be harder to see. The careful patterns our ancestors relied on would be disrupted. So how would we navigate? We'd use the rings themselves. Think about it. The rings sit directly above the equator, aligned perfectly with Earth's rotational axis. If you're standing anywhere on Earth and you can see the rings, their position tells you something about where you are. If the rings are directly overhead, you're at the equator. If they're low on the horizon, you're far from the equator, probably 20 or 30 degrees north or south. If you can't see them at all, you're in the higher latitudes beyond the ring's visibility. The rings become a cosmic latitude marker, precise and unchanging. Ancient navigators would have learned to read them the way we learn to read the stars. They'd develop techniques, tools, methods of measuring the angle of the rings against the horizon to determine position. Ring navigation would become an art, passed down through cultures, refined over centuries. But here's what we lose: the stars as universal guides. Polaris, the North Star, would still exist. It would still mark true north for those in the northern hemisphere. But its usefulness would diminish in equatorial regions where the rings dominate the sky. Travellers would need to rely on different techniques, different knowledge. And for those living beyond the ring's visibility, in Europe, Northern Asia, Canada, Scandinavia, southern Chile, New Zealand, they'd never see the rings at all. Their sky would remain relatively unchanged. They'd still navigate by stars, still use the old methods. Two different navigation systems, two different relationships with the sky. You can imagine the cultural implications. Equatorial civilizations might develop advanced ring-based astronomy early on, calculating distances and positions with remarkable precision. Northern and southern cultures might remain star-focused, developing entirely different cosmologies. Trade routes would be influenced by this divide. Knowledge would flow differently. Maybe equatorial navigators would be sought after for their expertise. Maybe northern sailors would be prized for their star knowledge when venturing beyond the ring zone. And then there's the question of timekeeping. We've used the sky to track time for as long as we've been human. The phases of the moon, the position of the sun, the seasonal shift of constellations. These rhythms have governed calendars, planting seasons, religious festivals. The rings would add another layer. Their shadow would move predictably across the equator each day, a kind of cosmic sundial. Ancient peoples might have used this to mark hours, to coordinate activities, to organize society. Imagine a culture where the day is divided not just by sunrise and sunset, but by the passage of the ring shadow. Where morning is defined by the shadow's arrival, and afternoon by its departure. Time itself would feel different. And at night, under those glowing rings, storytellers would gather. They'd point upward and spin tales, myths about how the rings formed, what they mean, why they guide us. The rings would become central to religion, to philosophy, to art. In some cultures, they might be seen as a bridge to the heavens. In others, a reminder of cosmic fragility. In still others, a mark of Earth's uniqueness, a crown placed on our world by forces beyond understanding. We navigate not just with tools and techniques, but with stories, with meaning. And a ringed Earth would give us entirely new meanings to explore. Rest here for a moment. Let your mind wander through those ancient skies beneath those glowing arcs. We'll continue soon. So far, we've been exploring the beauty of rings, the shadows they cast, the way they'd guide us, the stories we'd tell beneath them. But now we need to talk about something less poetic and more immediate. Rings fall, not all at once, not catastrophically, but constantly, gradually, particle by particle, they rain down on the planet below. This is the nature of ring systems. They're not permanent fixtures frozen in space. They're dynamic, evolving, slowly dying. Every ring system in our solar system is losing material, some faster than others. Saturn's rings, for example, are losing an estimated 2,000 kilograms of material every second, pulled down by the planet's gravity and magnetic field. If Earth had rings, The same process would happen here. Tiny particles of ice and rock would spiral inward, caught by atmospheric drag, pulled by gravity, gradually descending toward the surface. Most would burn up in the upper atmosphere, creating a constant faint meteor shower that would be visible every single night in equatorial regions. Imagine that. A sky where shooting stars aren't rare, special events, but a normal part of evening. Children would grow up watching the steady rain of light, pointing out the brightest streaks, making wishes on debris falling from the rings above. It sounds almost magical. But here's where it becomes a problem. We live in a different age now. We've filled the space around Earth with technology, satellites, thousands of them, orbiting at various altitudes, performing tasks we've come to depend on. Communication satellites relay phone calls and internet data. GPS satellites tell us where we are. Weather satellites track storms and climate patterns. Scientific satellites study Earth's atmosphere, oceans and land. And all of them would be in danger. Because ring particles don't just fall straight down, they drift, they spread. They occupy the same orbital space where our satellites need to be. At orbital speeds, thousands of miles per hour, even a tiny particle becomes a projectile. A piece of ring debris the size of a grain of sand travelling at 17,000 miles per hour hits with the force of a bullet. Something the size of a marble could disable a satellite completely. Something the size of a fist could destroy it utterly. This is called the debris problem, and it's something space agencies already worry about with our current population of satellites and space junk. But rings would make it exponentially worse. Launching satellites would become incredibly difficult. Every rocket would need to pass through the ring plane, that flat disk of orbiting material, to reach higher orbits. Some launch windows might become impossible. Others would require careful timing, threading the needle through gaps in the debris field. And satellites already in orbit. They'd need constant adjustments, constant monitoring, maneuvering to avoid incoming particles. Fuel would be consumed faster, lifespans would shorten, costs would skyrocket. Some orbits might become unusable entirely. The most crowded regions of the rings, where debris is densest, would be no-go zones. Satellites couldn't survive there. We'd lose access to certain altitudes, certain configurations that we currently rely on. Now, think about what that means for modern life. No GPS in your car, no Google Maps on your phone. Navigation becomes harder, slower, dependent on ground-based systems that don't have the same coverage or precision. Weather forecasting becomes less accurate. We lose the ability to track hurricanes with the same clarity, to predict storms days in advance, to monitor climate patterns from space. Communication networks would need to rely more on ground infrastructure, cables, towers, fiber optics. Remote regions that currently depend on satellite internet would lose connectivity. Scientific research would suffer. We wouldn't be able to study Earth from orbit the way we do now. Climate science, oceanography, atmospheric research, all would be set back. And space exploration, forget it. Getting beyond Earth's orbit would mean running a gauntlet through the rings. Every mission would carry enormous risk. The International Space Station, if it could even be built, would need to orbit below the rings or far above them, limiting its usefulness. We'd be trapped, in a sense. Not physically. We could still launch rockets, still reach space if we were careful and lucky. But practically, economically, the cost and danger would be so high that space travel might remain rare, limited, the domain of only the most critical missions. This is the paradox of rings. They're beautiful from the ground, but they're barriers in space. They make the sky more wondrous, and the cosmos harder to reach. And that's not even considering the material that actually makes it through the atmosphere. Most ring debris would burn up harmlessly, but not all of it. Larger fragments, anything bigger than a pebble, might survive the descent and reach the ground. Over centuries and millennia this would add up. A slow, steady rain of space material, falling primarily in equatorial regions. Most of it would land in oceans harmlessly, Some would hit unpopulated areas, but occasionally a piece would strike something important. A building, a city, a person. It wouldn't be common. The odds of any individual being hit would be vanishingly small, but statistically, over long enough timescales, it would happen. And that's the cost. That's the price of those glowing arcs in the sky. Beauty and danger, intertwined as they so often are in nature. We'll sit with that tension for a while before we move forward. Now let's step back, way back. We've been thinking in human timescales, years, decades, maybe a few centuries. But the universe doesn't think that way. Planetary systems evolve over millions of years. Ecosystems adapt across thousands of generations. So let's ask a different question. What does Earth look like after living with rings for a very, very long time? After the initial shock has faded, after civilizations have risen and fallen beneath those glowing arcs, after countless generations have been born, lived and died knowing nothing but a ringed sky. What becomes normal? First, let's talk about life itself. The plants, the animals, the intricate web of ecosystems that cover our planet. Life adapts. That's what it does. That's what it's always done. When the rings first formed, casting their shadows across the equator, disrupting light patterns, changing temperatures, there would have been stress. Some species would struggle. Migration patterns would shift. Food webs would reorganize. But over time, new equilibriums would emerge. Plants in the ring shadow zone would evolve to maximize their use of filtered, indirect light. They might develop larger leaves to capture more photons. They might adjust their photosynthetic chemistry to work more efficiently in dimmer conditions. Species that couldn't adapt would give way to those that could. Forests would change their character. The tropical rainforest we know, lush, dense, powered by intense equatorial sunlight, might thin out slightly, becoming more like the cloud forests found at higher elevations. New species would rise to dominance. Old ones would retreat to smaller ranges or disappear entirely. Animals would follow suit. Birds that navigate by celestial cues, the sun, the stars, the polarization of light, would develop new strategies. Perhaps they'd learn to navigate by the rings themselves, using them as fixed reference points. Perhaps they'd rely more on magnetic fields, on landmarks, on instinct refined over countless generations. Nocturnal creatures might struggle with the ring, glow at night. True darkness would be rare near the equator. Species that depend on darkness for hunting or hiding might shift their ranges toward higher latitudes, where the rings never appear and night remains night. Marine life would feel the effects too. Ocean temperatures would shift subtly. Currents would adjust. Coral reefs, already sensitive to small changes in light and temperature, might migrate to new latitudes or depths, seeking the conditions they need to thrive. But here's the remarkable thing. After enough time, all of this would simply be normal. A forest that evolved under ring shadows wouldn't be a damaged forest. It would be a ring-adapted forest, perfectly suited to its conditions, as healthy and vibrant as any forest we know today. Birds that navigate by rings wouldn't be confused. They'd be expert ring navigators, carrying knowledge encoded in their very biology. This is what deep time does. It transforms catastrophe into context. It turns disruption into the new baseline, and for humans, the same would be true. Imagine a civilization that has lived under rings for 10,000 years. For them, the rings aren't strange or threatening. They're just there, part of the sky, part of reality. Their agriculture would be optimized for ring shadow conditions. Their architecture would account for the unique light patterns. Their calendars would track not just solar and lunar cycles, but the seasonal movement of the ring shadow across different latitudes. Children would grow up drawing pictures of the rings the way our children draw the sun and moon. Poets would write verses about them. Musicians would compose songs inspired by their graceful arc. The rings would be woven into every aspect of culture, religion, art, science, philosophy. They'd be as fundamental to human experience as the ocean, the mountains, the changing seasons, and crucially, after enough generations, people wouldn't think of Earth as having rings. They'd think of rings as what Earth is. The concept of a ringless planet might seem strange, incomplete, even a little sad. Can you imagine, someone might say, a sky without rings? How empty it would look, how lonely. This is the power of adaptation, not just biological but psychological and cultural. We humans are remarkably good at normalizing our circumstances, whatever they may be. We find meaning in what we're given. We build beauty around the constraints we face. In some ways, this is comforting. It tells us that even dramatic changes to our world don't have to mean the end of flourishing. Life finds a way. People find ways. Meaning emerges from whatever context we inhabit. But in other ways, it's a little unsettling, because it means we can adapt to almost anything, even things that, from an outside perspective, might look limiting or dangerous or less than ideal. We make our peace with the world we're born into. We call it home. And a ringed Earth, for all its challenges and complexities, would eventually feel like home too. The rings would simply be part of the sky, part of us. And perhaps that's the deepest truth we're exploring here tonight. Not just what rings would do to Earth, but what Earth would do with rings, how we'd absorb them, adapt to them, find beauty and meaning in them, how we'd make them ours. Rest with that thought for a moment. Let it settle. There's more to explore, but we have time. We always have time. Let's slow down now and simply look. Let's take a journey across Earth and witness what the rings would actually look like from different places on our planet. Because the view wouldn't be the same everywhere. Geometry determines what you see, and where you stand determines everything. Start with us at the equator. Let's say we're standing in Ecuador or Kenya or Indonesia, somewhere where Earth's imaginary line wraps around its widest point. Look up. The rings stretch directly overhead, running from the eastern horizon to the western horizon in a perfect luminous arc. They're widest at the zenith. They point directly above you, and they narrow as your eyes follow them toward each horizon until they seem to converge at distant vanishing points. During the day, you might not see them clearly. The sun's brightness washes them out, though you'd notice a subtle brightening along their path, a shimmer in the sky's blue. But at sunset, that's when the magic happens. As the sun dips below the horizon, its light still catches the rings high above. They begin to glow, softly at first, then brighter, painted in shades of gold and orange and pink. The rest of the sky darkens, but the rings remain illuminated, a glowing bridge across the heavens. This is called ring shine, and it would be one of the most beautiful sights in nature. For perhaps an hour after sunset, you'd stand in twilight on the ground while the rings blazed with reflected sunlight above. Then gradually, as Earth's shadow climbs higher, the glow would fade section by section until only the faintest silver light remains. At night, under a full moon, the rings would shimmer again, pale and ghostly, bright enough to cast faint shadows on the ground. Now let's travel north. We'll go to Mexico City, about 19 degrees north of the equator. Here, the rings no longer pass directly overhead. Instead, they arc across the southern sky, still prominent, still beautiful, but lower. You'd see them stretching from southeast to southwest, maybe 40 or 50 degrees above the horizon at their highest point. The view is still breathtaking, but it's different. The rings look more like a distant bridge, something you're viewing from afar rather than standing beneath. Keep traveling north, Miami, Atlanta, Washington, D.C. With each step northward, the rings sink lower in the sky. From Washington, at about 39 degrees north, the rings would hug the southern horizon, a low, shimmering band that you'd need a clear view to see properly. Buildings and trees might block portions of it. On a clear night, though, you'd still catch glimpses, that ethereal glow along the southern edge of the world, and then, somewhere around 40 to 45 degrees north, around the latitude of Northern California or Rome or Northern Japan, the rings disappear below the horizon entirely. If you lived in London or Toronto or Moscow, you would never see Earth's rings, not even a sliver. They'd be permanently hidden by the curve of the planet, forever out of view. You'd know they existed, of course. You'd see photographs, you'd hear stories from travellers who'd journeyed south. But your sky would remain ringless, stars and moon and planets, much like the sky we know today. The same would be true in the Southern Hemisphere. From Sydney or Cape Town or Buenos Aires, the rings would be invisible, hidden beyond the northern horizon. Two experiences, two Earths, in a sense. Those who live beneath the rings and those who don't. And maybe, just maybe, people would travel simply to see them, to stand at the equator and witness that glowing arc overhead, to experience just once what it means to live under a sky adorned with rings, tourism of wonder, pilgrimage to beauty, because some sights are worth crossing the world to witness, and rings, if we had them, would be among the greatest. Let's pause our journey across Earth and ask a quieter, deeper question. Why does Saturn have rings, and we don't? It's not a matter of luck exactly, it's physics. It's the patient, predictable mathematics of gravity and motion, playing out over billions of years. We mentioned the Roche limit earlier, that boundary where a planet's gravity becomes strong enough to tear apart anything that comes too close. Every planet has one. Earth's, Mars's, Jupiter's, Saturn's. But having a Roche limit isn't enough to create rings. You also need something to break apart within that zone. A moon that wanders too close. An asteroid that gets captured. A comet that fractures during a near pass. Saturn has rings because at some point in its history, maybe billions of years ago, maybe more recently, something crossed that threshold and shattered. Maybe it was a small moon. Maybe it was a captured object from elsewhere in the solar system. We're not entirely certain. What we do know is that once those fragments settled into orbit, they stayed there. Saturn's rings have persisted, organised by gravity into thousands of individual ringlets, separated by gaps carved out by the gravitational influence of Saturn's many moons. Earth, so far, hasn't had that happen. Our moon orbits far beyond the Roche limit, stable and safe. We don't have a population of small moons close enough to be at risk, and while asteroids occasionally pass near Earth, none have been captured and torn apart in exactly the right way to create a lasting ring system. So we orbit the Sun alone, unadorned. But that doesn't mean it couldn't happen. In Earth's distant past, about 4.5 billion years ago, a Mars-sized object called Theia collided with our young planet. The impact was catastrophic. It melted Earth's surface, ejected enormous amounts of material into space, and from that debris, our moon formed. Some scientists have suggested that briefly Earth might have had rings during that period. Material from the impact would have orbited in a disk before gradually coalescing into the moon we know today. If that's true, then Earth was once a ringed planet, just for a little while, in an age before life, before oceans, before anything we'd recognise as home. And it could happen again. Not likely, but possible. If a large asteroid were captured by Earth's gravity in just the right way, pulled into a decaying orbit, it might eventually cross the Roche limit and break apart. Or if something catastrophic happened to the moon, a massive impact, though incredibly unlikely, fragments could be scattered into closer orbits. These are remote possibilities, cosmic long shots. But the universe is patient, and over deep time, even unlikely things sometimes occur. What's more certain is this. All ring systems are temporary. Saturn's rings won't last forever. They're losing material constantly, raining down onto the planet below. Current estimates suggest they might only be a few 100 million years old, young in cosmic terms, and they'll likely disappear within another 100 million years or so. Rings are transient. Beautiful, yes, but not eternal. If Earth somehow gained rings tomorrow, they too would eventually fade. Particles would fall. Collisions would grind material into finer and finer dust. Solar radiation would push the smallest particles out of orbit. The moon's gravity would tug and disrupt. Over millions of years, the rings would thin, dim, and finally vanish, leaving only a faint trace of dust and a memory in whatever civilizations witnessed them. This is the nature of rings. They're moments in geological time, brief decorations on planets lucky, or unlucky, enough to acquire them, and maybe that makes them more precious, more worth contemplating, because the most beautiful things in the universe are often the ones that don't last forever. Now let's think about what rings would mean, not just physically, but psychologically, culturally, spiritually, because we humans don't just live in the world, we interpret it, we make meaning from it, and a ringed Earth would give us entirely new meanings to explore. Imagine being an ancient person, standing beneath those glowing arcs for the first time. You have no knowledge of orbital mechanics, no understanding of gravity or debris fields. All you know is that something vast and beautiful spans the sky, permanent and unchanging. What would you think? Maybe the rings are a bridge, a path the gods use to travel between heaven and earth. Maybe they're a river, flowing with celestial water. Maybe they're the bones of some cosmic serpent, wrapped around the world to hold it together. Every culture would develop its own stories, its own explanations. In some traditions, the rings might be seen as protective, a shield placed around Earth by divine forces, keeping us safe from the chaos beyond. In others, they might be a reminder of cosmic catastrophe, the shattered remains of something that came too close and was destroyed. Religious texts would reference them. Creation myths would explain how they came to be. Prophets might interpret changes in their brightness or position as omens, signs of blessing or warning. The rings would become sacred. Temples might be built to align with them. Priests might study their movements, tracking the way sunlight shifts across their surface through the seasons, developing calendars and rituals based on ring cycles. And perhaps most profoundly, the rings would change our sense of perspective. Right now, most of us go through our daily lives without thinking much about our place in the cosmos. We know, intellectually, that we live on a planet orbiting a star in a vast galaxy, but we don't feel it. The sky is just up there, distant, abstract. But rings would be impossible to ignore. Every time you looked up time, you'd see evidence of cosmic forces at work. You'd be reminded that you live on a sphere orbiting in space, held by gravity, part of a larger system. Children would grow up with this awareness baked into their consciousness. Philosophers would contemplate what it means to live beneath such a structure. Artists would spend lifetimes trying to capture their beauty. And our sense of uniqueness, our understanding of Earth's place in the universe, would shift. Right now, Earth feels special, partly because it looks different from the other planets in our solar system. We're the blue world, the living world, the one without rings. But if we had rings, we'd be more like Saturn, more like Uranus and Neptune. We'd join the club of ringed worlds, losing some of that distinctiveness. Would that make us feel less special? Or would it make us feel more connected to the broader cosmos, part of a pattern, a type, a category of planets that wear rings like crowns? Different cultures would answer differently. Some might feel diminished, their home less unique, less chosen. Others might feel elevated, marked by rings as significant, adorned by the universe itself. And there would be those who simply found comfort in it. The idea that Earth is not alone in wearing rings, that elsewhere in the universe, other worlds circle their stars with debris halos of their own, that we're part of something larger. This is what rings would do to us, perhaps more than anything physical. They'd make the cosmos unavoidable. They'd put the universe directly overhead, every single day, impossible to forget. And maybe that would change us, make us more curious, more humble, more aware of the forces that shape our world. Or maybe not. Maybe we'd simply adapt, normalize, forget to look up. That's the mystery of human nature. We can live beneath wonders and eventually stop seeing them, but every so often someone would remember to look, and they'd be amazed all over again. Now let's think about what rings would mean, not just physically, but psychologically, culturally, spiritually, because we humans don't just live in the world, we interpret it, we make meaning from it, and a ringed Earth would give us entirely new meanings to explore. Imagine being an ancient person, standing beneath those glowing arcs for the first time. You have no knowledge of orbital mechanics, no understanding of gravity or debris fields. All you know is that something vast and beautiful spans the sky, permanent and unchanging. What would you think? Maybe the rings are a bridge, a path the gods use to travel between heaven and earth. Maybe they're a river, flowing with celestial water. Maybe they're the bones of some cosmic serpent, wrapped around the world to hold it together. Every culture would develop its own stories, its own explanations. In some traditions, the rings might be seen as protective, a shield placed around Earth by divine forces keeping us safe from the chaos beyond. In others, they might be a reminder of cosmic catastrophe, the shattered remains of something that came too close and was destroyed. Religious texts would reference them. Creation myths would explain how they came to be. Prophets might interpret changes in their brightness or position as omens, signs of blessing or warning. The rings would become sacred. Temples might be built to align with them. Priests might study their movements, tracking the way sunlight shifts across their surface through the seasons, developing calendars and rituals based on ring cycles. And perhaps most profoundly, the rings would change our sense of perspective. Right now, most of us go through our daily lives without thinking much about our place in the cosmos. We know, intellectually, that we live on a planet orbiting a star in a vast galaxy, but we don't feel it. The sky is just up there, distant, abstract. But rings would be impossible to ignore. Every time you looked up, you'd see evidence of cosmic forces at work. You'd be reminded that you live on a sphere orbiting in space, held by gravity, part of a larger system. Children would grow up with this awareness baked into their consciousness. Philosophers would contemplate what it means to live beneath such a structure. Artists would spend lifetimes trying to capture their beauty. And our sense of uniqueness, our understanding of Earth's place in the universe, would shift. Right now, Earth feels special, partly because it looks different from the other planets in our solar system. We're the blue world, the living world, the one without rings. But if we had rings, we'd be more like Saturn, more like Uranus and Neptune. We'd join the club of ringed worlds, losing some of that distinctiveness. Would that make us feel less special? Or would it make us feel more connected to the broader cosmos, part of a pattern, a type, a category of planets that wear rings like crowns? Different cultures would answer differently. Some might feel diminished, their home less unique, less chosen. Others might feel elevated, marked by rings as significant, adorned by the universe itself. And there would be those who simply found comfort in it. The idea that Earth is not alone in wearing rings, that elsewhere in the universe other worlds circle their stars with debris halos of their own, that we're part of something larger. This is what rings would do to us, perhaps more than anything physical. They'd make the cosmos unavoidable. They'd put the universe directly overhead, every single day, impossible to forget. And maybe that would change us, make us more curious, more humble, more aware of the forces that shape our world. Or maybe not. Maybe we'd simply adapt, normalize, forget to look up. That's the mystery of human nature. We can live beneath wonders and eventually stop seeing them, but every so often someone would remember to look, and they'd be amazed all over again. Let's bring ourselves back to reality for a moment. Back to our Earth, unringed and familiar, orbiting quietly through space. Could this actually happen? Could Earth really gain rings? The honest answer is, it's unlikely, but not impossible. Let's walk through the scenarios, the ways, however remote, that our planet might one day find itself adorned with a ring system. The first possibility is asteroid capture. Earth's gravity occasionally captures small asteroids into temporary orbits around our planet. These mini-moons don't last long, usually just a few months or years before they either escape back into solar orbit or fall to Earth. But imagine if a larger asteroid, perhaps a few miles across, were captured in just the right way. If its orbit decayed slowly, bringing it closer and closer to Earth over thousands of years, it might eventually cross the Roche limit. At that point, tidal forces would pull it apart, and the fragments would spread into a ring. It's possible. But the odds of capturing an asteroid in exactly the right orbit, with exactly the right trajectory, are vanishingly small. The second scenario involves our Moon. The Moon is moving away from Earth, not toward it, drifting outward at about 1.5 inches per year due to tidal interactions, so there's no danger of it falling inward and breaking apart. But what if something hit the Moon? A massive asteroid impact large enough to blast material off the lunar surface and scatter it into orbit around Earth. Again, it's possible in theory. Space is full of asteroids. Impacts happen. The Moon's surface is covered with craters proving this. But an impact large enough to create a ring system around Earth, not just around the Moon, but around Earth, would need to be extraordinarily powerful. And those kinds of impacts are rare. We're talking once every tens or hundreds of millions of years, if that. Still, the universe is very, very old, and it will continue for a very, very long time. Over billions of years, unlikely things become somewhat likely. Rare events eventually occur. There's a third, more disturbing possibility: human-made rings. Right now, Earth is surrounded by thousands of satellites and millions of pieces of space debris, dead satellites, rocket stages, fragments from collisions. This junk orbits at various altitudes, some of it for decades or centuries. If we're not careful, if we continue launching satellites without proper disposal plans, we could create what's called Kessler syndrome, a cascade of collisions where debris hits satellites, creating more debris, which hits more satellites, creating even more debris. Eventually, certain orbital zones could become so cluttered with fragments that they form a kind of artificial ring. Not beautiful arcs of ice and rock, but a shell of human-made wreckage. It wouldn't look like Saturn's rings. It would be messy, chaotic, invisible to the naked eye from the ground, but it would have some of the same effects, making space travel more dangerous, threatening our satellites, raining debris down into the atmosphere. This scenario is actually the most plausible of all the ones we've discussed. Not certain, but genuinely possible within the next century or two if we're not careful. It's a sobering thought. The rings we might create ourselves wouldn't be gifts from the cosmos. They'd be consequences of carelessness. But let's step back from that darkness for a moment. The truth is, Earth probably won't have rings. Not natural ones, at least. We've existed for billions of years without them. The conditions that create ring systems are specific, and we don't meet them. We're a ringless world. And maybe that's okay. Maybe that's even special. Because it means when we look up at night, we see stars clearly. We see the Milky Way stretching across the darkness. We see other planets, distant and clear, without interference. Our sky is open, unobstructed, wide, and perhaps there's beauty in that too. We've spent so much time imagining rings around Earth, but let's take a moment to visit the places where rings actually exist. Let's travel outward through our solar system and see what's really out there. Saturn, of course, is the most famous, the ringed jewel of our planetary neighbourhood. When Galileo first turned his telescope towards Saturn in 1610, he saw something strange. Bulges on either side of the planet that he couldn't quite understand. His telescope wasn't powerful enough to resolve the rings clearly. He thought perhaps Saturn had ears, or was a triple planet. It wasn't until decades later that astronomers realised what they were seeing: a magnificent ring system, tilted relative to Saturn's orbit, sometimes edge-on and invisible, other times open and spectacular. Saturn's rings are enormous, about 175,000 miles across, but astonishingly thin. If you could shrink them down proportionally, they'd be thinner than a sheet of paper. They're made mostly of water ice, mixed with some rock and dust. Billions upon billions of particles ranging from grains of sand to chunks the size of houses, all orbiting in elegant ordered bands. And they're beautiful beyond description, the way sunlight catches them, the gaps carved by gravitational resonances with Saturn's moons, the delicate braids and kinks and waves rippling through them. If you could stand on one of Saturn's moons and watch the rings arc across the sky, you'd witness one of the most stunning views in the entire solar system. But Saturn isn't alone. Jupiter has rings too, faint, dusty, barely visible. They were discovered not by ground-based telescopes, but by the Voyager 1 spacecraft in 1979, when it flew past Jupiter and caught them in a long-exposure photograph. Jupiter's rings are made of fine dust, probably blasted off its small inner moons by micrometeorite impacts. They're dark, tenuous, nothing like Saturn's grandeur. But they're there. Uranus has rings, narrow dark bands, discovered in 1977 when astronomers noticed that a distant star briefly blinked out as Uranus passed in front of it. The star dimmed multiple times before and after the planet blocked it, revealing the presence of previously unknown rings. Neptune has rings too, also narrow, also faint, discovered by similar methods. Even some asteroids have rings. Chariklo, a small body orbiting between Saturn and Uranus, has 2 narrow rings. We're not entirely sure how they formed, but they're real. And beyond our solar system, we found evidence of rings around exoplanets, distant worlds orbiting other stars. In 2012, astronomers detected what appeared to be a massive ring system around a young star called J-Utamsorofindven. The rings were enormous, much larger than Saturn's, suggesting that ring systems might be common during the formation of planetary systems. Young planets, surrounded by disks of debris left over from their formation, gradually clearing those disks as moons form and material falls inward. Rings, it seems, are part of the process of planetary birth, which means that somewhere out there, on planets we'll never visit, beings might be looking up at their own ringed skies. They might have their own myths, their own navigation systems, their own relationship with the cosmic arcs overhead. They might wonder, as we do, what it would be like to live on a world without rings. Would they pity us, envy our clear skies, simply find it strange? We'll never know. The distances are too vast. We can barely detect exoplanets, let alone study them in detail or communicate with anyone who might live there. But it's comforting in a way to know we're not the only planetary system with rings. That out there, scattered across the galaxy, other worlds wear their own crowns of debris. That rings are not unique, not singular, but part of the broader pattern of how matter behaves in the cosmos. We're part of something larger. We always have been, and whether Earth has rings or not, we're connected to all those distant worlds by the same physics, the same gravity, the same ancient processes that shape planets and moons and the space between. That's worth remembering. Rest here for a moment beneath our ringless sky and feel that connection. We'll continue soon. There's something we need to sit with for a moment. Something important about the nature of the universe itself. Rings would be beautiful. We've established that. Breathtaking even. One of the most stunning sights nature could offer, and they would also be dangerous, disruptive, challenging in ways that would ripple through every aspect of life on Earth. Both things are true, simultaneously, without contradiction. This is the paradox we've been circling throughout this entire journey. Beauty and danger are not opposites in nature. They're often companions. Sometimes they're the same thing, viewed from different angles. Think about a hurricane. From space, it's a perfect spiral, elegant, symmetric, mesmerizing in its structure. The eye, calm and clear. The cloud bands swirling with mathematical precision. Beautiful. And on the ground, devastating. Homes destroyed, lives upended, communities struggling to rebuild. Or consider a supernova, the explosion of a dying star. One of the most luminous events in the universe, visible across millions of light years. The colours, the energy, the sheer cosmic drama of it. Magnificent. And anything nearby, incinerated. Planets stripped of their atmospheres. Life wiped away in an instant of radiation. Nature doesn't care about our categories. It doesn't separate things into good and bad, safe and dangerous, beautiful and threatening. It simply is. It follows laws, gravity, thermodynamics, chemistry, physics, with perfect indifference to how we might feel about the results. Rings are part of that same indifference. They would form because of gravity, not because the universe wanted to give us something lovely to look at. They'd cast shadows because of orbital mechanics, not because anything intended to disrupt our ecosystems. They'd fall as debris because that's what ring particles do, not because of malice or design. The universe is not cruel, but it's not kind either. It's simply itself, operating according to principles that existed long before we did and will continue long after we're gone. And we, as conscious beings capable of perceiving beauty and experiencing danger, have to hold both truths at once. We have to be able to say, this is gorgeous and this could harm us. We have to appreciate the wonder while also acknowledging the cost. This is true not just for rings, but for so much of existence. Fire is beautiful and it burns. The ocean is sublime and it drowns. Mountains inspire awe and they kill climbers. The sun gives us life and it will eventually consume our planet. Everything that sustains us also limits us. Everything that inspires us also endangers us. And maybe that's okay. Maybe the goal isn't to live in a world where everything is perfectly safe and nothing ever threatens us. Maybe the goal is to learn to exist alongside danger, to find beauty in things that could harm us, to appreciate wonder even when it comes with risk. Indigenous peoples around the world have always understood this. They've lived for millennia in close relationship with nature, with rivers that flood, volcanoes that erupt, forests that burn, storms that rage. They don't see these forces as enemies. They see them as relatives, powerful, unpredictable relatives that demand respect and caution, but relatives nonetheless. Part of the family, part of home. Rings, if we had them, would become the same. We'd learn to live with them. We'd adapt our technologies, our cultures, our expectations. We'd teach our children to watch the sky, to track the debris, to appreciate the beauty while respecting the danger. We'd build our relationship with them carefully, over generations. Because that's what we do. That's what we've always done. We find ways to exist alongside forces much larger than ourselves. And in doing so, we find meaning, purpose, connection to something beyond our individual lives. Rings wouldn't make Earth a worse place or a better place. They'd make it different, more complex, more layered, and we'd make it home. And so, we arrive at the end of our journey. Or perhaps not the end, just a resting place. A moment to look back at where we've travelled together. We began by imagining a sky transformed, rings stretching from horizon to horizon, glowing in the twilight, casting shadows across continents. We walk through 5 stages of change: formation, light and shadow, navigation, debris, and the long adaptation of life itself. We stood at different latitudes and witnessed how the view would shift. We explored the science of why rings form and why they fade. We considered what they'd mean culturally, spiritually, psychologically. And through it all, we've been asking a deeper question. What does it mean to live on a planet? What does it mean to call a place home when that place is shaped by forces far beyond our control? Earth, as we know it, is a gift of circumstance. The right distance from the sun, the right size to hold an atmosphere, water in abundance, a moon that stabilizes our tilt, and yes, a clear sky, unobstructed by rings. We didn't earn any of this. We simply arrived here, evolved here, became conscious here, and looked around in wonder. And we could just as easily have arrived on a different Earth, one with rings, one where shadows danced across the equator every day, one where the night sky glowed with reflected light and navigation required different skills and satellites were nearly impossible? Would life have emerged differently? Would we be different people, shaped by a different sky? Maybe, maybe not. What seems certain is this: we would have found beauty in it. We would have made meaning from it. We would have called it home. Because that's what consciousness does. It finds patterns, it creates stories, it looks at the universe, indifferent, mechanical, governed by physics, and it feels something. Awe, wonder, fear, gratitude. The universe doesn't need us to feel these things. It would go on existing perfectly well without observers, without anyone to appreciate its sunsets or its ring systems or its spiraling galaxies. But we're here anyway, watching, wondering, making meaning from the vast impersonal machinery of existence. And maybe that's enough. Maybe the fact that we can imagine rings around Earth, that we can explore the science, the consequences, the beauty and danger of them, maybe that itself is a kind of gift, not from the universe, which doesn't give gifts, but from whatever process led to us being here, capable of curiosity, capable of looking up. So tonight, before you sleep, maybe take a moment to look at the real sky, the one we actually have. No rings, just stars, the moon if it's visible, planets perhaps, small and bright, the Milky Way if you're far from city lights. It's beautiful too, in its own way, quiet, open, clear, and it's ours. We orbit the sun on this small world, unadorned by rings, and that's perfectly okay. We have what we have, we are where we are, and if you've enjoyed this exploration, this slow journey through cosmic possibilities, maybe consider subscribing. There are so many more questions to ask, so many more places to visit together, in thought if not in body. The universe is vast, patient, full of wonders both real and imagined, and we have time, all the time we need. Thank you for spending this time with me, here in the quiet of the night. Thank you for wondering, for imagining, for staying curious about this strange, beautiful cosmos we inhabit. Rest well. Dream of rings if you like, or of clear skies, or of nothing at all. The universe will be here tomorrow, and so will we. The universe is patient, so are we.